Hey guys, so today we're looking at angles of elevation and depression. So, as the words state themselves, the angle of elevation is the angle measured up. So, elevation is up. So, and it's measured from the horizon. So, as you can see in my diagram, the blue angle right here is the angle measured up. Like that's the line of sight from this person. It's the angle measured from the horizon, upwards. Whereas the angle of depression is the angle measured down. So we've got depression and down, okay? And that's measured from a line parallel to the horizon. So it could be anywhere and it's measured down. So you can see the differences between these two angles. Now, something special about this is that the angle of elevation is actually equal to the angle of depression. And the reason why that is because come back to when we learnt parallel lines in year 8. These are our two parallel lines. When the transversal cuts those lines, this Z shape formed are alternate angles. And that would be our flat horizon, and this is a line parallel to the horizon. So that angle there is an alternate angle to the angle of elevation, which means those two angles are actually equal. Now that's really handy when we're dealing with these problems. So, because we've got these diagrams and this is our angle, notice that they both form right-angled triangles. Now, using our right-angled triangle, that would mean, like most of the time, tan ratio is used because this is our opposite and the flat line is our adjacent, and it's the same. This is our, So, you'll know why for this triangle in a minute. When you solve angle of depression problems, there's two ways you can do it. You can form a triangle here, okay? Because most of the problems will be like, it'll give you the angle of depression and it'll say how far away is the boat kind of thing. So you can form a right-angled triangle right there, okay? Or you can use the fact that these would be alternate angles, which means that that angle is equal to this angle in here. So you've automatically created an angle of elevation. And I'll show you what I mean in a minute, which is why I said the tan ratio is usually used. Another important thing is you always must draw a diagram. So both examples I'm using today, I'm not drawing the picture. I'm not showing you the picture. I'm going to show you how to draw it. So, the angle of elevation of a chimney is 49 degrees at a distance of 85 meters from the base. Find the height. So, the key word here is angle of elevation. So, I'll do that in blue. So, it doesn't have to obviously be like a good drawing. As you can see, mine are horrible. So, we're going to draw a chimney. As so. Okay. That's the smoke coming out of the chimney. And we've got the angle of elevation is 49 degrees at a distance of 85 meters from the base. So if this is our chimney, they're just bricks, obviously. If we've got the base of our chimney, it says that the angle of elevation to the top is 89 degrees. So our angle of elevation is 49 degrees, sorry. And it gives it that angle 85 meters from the base. So what that means is that this distance along the bottom is 85 meters. And it says find the height. So let's call the height x. As you can see, what we have created is a right-angled triangle, okay? And that's the whole point. So with our right-angled triangle, this is our angle. We've got the opposite side and the adjacent side. So because we're trying to find x, we're going to use tan. So we're going to go tan, remember tan theta is opposite over adjacent. So we've got tan of 49 degrees is equal to the opposite, which is x, over the adjacent, which is 85. So again, we've now got an equation that we just solved for x. So we multiply by 85. Remember that gets rid of this guy on the denominator, the opposite. And then we've got x is equal to 85 times tan of 49. You put that into your calculator and you'll get 97.781, and because we're going to the nearest meter, that's approximately 98 meters. which kind of makes sense, right? Like if this is a right angle triangle, that's 85, that would be 98. Okay? All right, number 2. The angle of depression of a boat from the top of a cliff is 8 degrees. If the boat is 300 meters from the base of the cliff, calculate the height of the cliff to the nearest meter. So this time we're looking at the angle of depression. Okay, so we've got a boat. Okay, so the angle of depression of a boat from the top of a cliff. So here's our top of a cliff, and here's our boat. All the time there are triangles created. You're welcome for the art. Okay, so angle of depression, let's draw a line. It is 8 degrees. So remember, this angle in here is not the angle of depression. It's not there. It's the line that is parallel with the horizon. So what you're going to have to do for these ones is draw a line parallel. Our horizon in this case is the water. Okay. Oops, my boat is not on the water. Alrighty. And then it says that the angle of depression, is 8 degrees. So that means this angle in here is 8 degrees. If the boat is 350 meters from the base of the cliff, so here's our cliff. The base of the cliff is here and it's 350 meters from the base. What that means is that this distance is obviously 350 meters. And again, as you can see, we've sort of formed this right-angled triangle. Well, it is a right-angled triangle. Calculate the height of the cliff. So again, we're going to calculate the cliff, which let's call x. Here again, we've got a right-angled triangle. Now, you can do 2 things here. What you can do is, because of the... we can go 2 ways. Obviously, you can't use this triangle to help us really find... Well, we can, I guess. You can kind of like draw a line down here, if you like, and see how we've created this triangle with that angle as 8 degrees. If you found that height and redrew the triangle, it would give you the same as this length. Or what you can do is, because since the angle of depression... Oh my God. Why did I do that? D equals elevation. If that's 8 degrees, that must mean that that angle in here is also 8 degrees. And so we can just do the same thing we did before and calculate our angle, our length, using our angle of elevation. So that's what I mean. They're equal to each other, and that's because these lines are parallel. So again, we're going to use tan because we've got the opposite and the adjacent. So tan of 8 degrees is equal to the opposite, which is x, over the adjacent, which is 350. Multiplying out by 350, we get x is equal to 350 times tan of 8. Now, probably annoying, but all I've done is just switch these two. So that would say, this would say 350 times tan of 8 is equal to x, because they cancel each other out, and that's the same as reversing the statement. So when you put that into your calculator, you get 49.189, and we're going to the nearest meter, so that's 50 meters. So this is method 1. Another way you can do it is by having a look. Remember, this is what we've got. If this is 90 degrees, that means that is also 90 degrees, right? Because it's like making it with the, how do I say it? well, actually, no, this is what I'm trying to say. That's 90 degrees. We know that in our triangle, it all adds up to 180, which means that if that's 90 degrees, then these two angles have to add up to 90. So another roundabout way of doing it is that this angle in here would be 90 minus 8 degrees, because you've got the 8 degrees down here, and then the leftover has to be up here to make it 180. So that's actually 82 degrees. And we can use then the triangle here using 82 degrees as our angle. So again, we'd have X. This would be 82 degrees, and that would be 350. So you can actually do it that way as well. And this time you would be using a different trig ratio. No, sorry, it's still tan, because you've got the adjacent, which is X. So tan of 82 is equal to the opposite, oh my God, opposite, which is 350 over X. And remember the little trick I told you can just switch them? And you'll find if you put that into your calculator, you obviously get the same answer because we're still measuring that same side, right? And that's it. That's obviously, I think method 1's easier, but that's just another way that you can do it. Okay, and that's it.